Hi, my name is Thane Muntz. I'm an assistant scientist and director of the Athletic Health and Performance Lab at Sanford Research in Sioux Falls, South Dakota. Our team at Sanford Research, together with collaborators from the Health and Technology District and Simon Fraser University in Surrey, British Columbia, Canada, recently published a study in brain communications titled Subconcussive Changes in Youth Football Players, Objective Evidence Using Brain Vital Signs and Instrumented Accelerometers. In this study, we evaluated the brain vital signs of 15 male youth football players between the ages of 12 and 14 using portable electroencephalography technology to analyze brainwaves. We also monitored the head impacts that players incurred throughout the season using the head impact telemetry system, which uses helmet-mounted accelerometers to measure head impact frequency and severity. We found significant pre- to postseason changes in brain vital signs in these players that were specifically related to cognitive processing speed. These changes occurred in the absence of a concussion, meaning they were subconcussive. In other words, the players had no associated signs, symptoms, or diagnosis of a concussion. These subconcussive changes were also significantly related to the number of impacts that players experienced in games, as well as the total number of sessions that they participated in throughout the season. These findings replicate the results from some members of our team working with Junior A and Bantam ice hockey players, in which significant changes in brain vital signs were measured in concussed players and players who had not suffered a concussion.
Hi, my name is Dr. Sean Fickling. I was the lead author of this study, which was conducted as part of my PhD research at Simon Fraser University in British Columbia, Canada. Brain vital signs are based on EEG technology and specifically event-related potentials, or ERPs. And this is a well-established, non-invasive physiological measure of brain activity that is both portable and accessible. ERPs can be generated by stimulating the brain through sensory input and measuring the brain's responses. Responses to specific pattern changes embedded in the stimulus provide objective, quantifiable information across a spectrum of brain function. The brain vital signs framework is a process built on top of that to record these metrics and rank them in a way that is clinically relevant. The objectives of the study were to expand upon our previous research in ice hockey and examine the relationship between the number of subconcussive impacts that football players were exposed to over the course of the season and the corresponding changes in brain vital signs measured before the season and at the end of the season. The findings of the study were really interesting. Firstly, we noticed significant changes in the N400 measure of cognitive processing between preseason and postseason in all of the players. And in the absence of a concussion, this suggests some sort of impairment from repetitive subconcussive head impacts. In addition, we noticed that the changes in brain vital signs were highly predictive of the number of impacts that the players were actually exposed to over the course of the season as a measure of the total impacts, but also, interestingly, just the total number of practices and games that the players participated in. And this suggests that exposure to head impacts through participation in contact sport is a significant predictor of changes in brain vital signs.
There has been extensive research on concussions in contact collision sports over the last 20 years. However, there is growing interest in studying the effects of repetitive subconcussive head impacts on both short-term and long-term brain health. While detecting subconcussive changes in cognitive function of youth football players is somewhat sobering and certainly prompts the need for additional research, we are encouraged that we now have a tool that can provide rapid and early detection of these changes, which may give us an opportunity to better manage the risk and to mitigate adverse health outcomes. We hope that this approach of monitoring brain vital signs in concussed and subconcussed individuals will ultimately improve our understanding of brain injury risk in sport and protect the health and safety of athletes in the future. For more information about this work, I encourage you to access and read the full paper on the Brain Communications website. Thank you.